Assalamualaikum and hi everyone. Me and my friend would like to present about our group assignment 2. Firstly, my name is Nur Shahira binti Muhammad and my metric number is 277077 and my friend name is Nur Shazwani Zahira binti Zafri. The number metric is 2772884 and our lecturer name is Dr. Muhammad Farhan Muhammad Mohsin. So this is our salary data set. Year experience as the independent variable and salary is our target. The first question from our group assignment 2 is determine type of learning. Type of learning from our dataset is supervised that aim to find association between independent variable and decision class that contain target or decision class in machine learning based on guided training. The second question is describe the model that you plan to develop. So our model is prediction model that is appropriate algorithm is suitable that can apply to develop the model. The third question A is give the brief explanation about the algorithm. Algorithm is machine learning that conventional algorithm. Machine learning can play the role without algorithm is inflexible. Machine learning is suggestion or to figure out the best solution and classical algorithm is more detailed like if you want to describe someone, we must know what their able shape, able color and so on. Algorithm is that trained on a data set to make prediction or classification or take action like find pattern, similarities in order to optimize some system. 3B question is justify why the algorithm is selected to build the model. As we know, supervised learning have two categories of algorithm that is prediction and classification. We choose to use prediction of regression that is linear regression. Linear regression is one of machine learning algorithms that try to develop to produce a prediction model. The M linear regression is want to know what is the best combine between M and C. The 3C question is determine the output of knowledge that can be extracted from the algorithm. Firstly, we must call the related library and the second load the data. So the data will come out. So this is our data. We also can check the total number record for salary and write salary.count bracket and the total number record is 35. The third step is perform data exploration. So we focus on years experience to predict the numbers. So we write salary.plot kind scatter x is year experience and y is salary alpha 0.2 to see year experience and salary to see the relationship. So this is a relationship between x and y. Linear regression has a positive relationship when year experience is increased and salary also increase. The correlation. We can check the correlation when to know how strong the relationship. So we write salary, year experience, dot core. So we can check the correlation. The value of correlation is 0.982427. Correlation coefficients are used to measure the strength of the relationship between two variables. Value always range between -1, strong negative relationship, and +1 is strong positive relationship. A correlation of 0.0 show no linear relationship between the movement of the two variables. But if the value is close to 0, so the value is less strong. So this is histogram. We can see year experience and salary. The scatter plot. We don't have to call the library because we already changed the seaborn to SNS. So we write SNS.implot, X is year experience and Y is salary. Calling linear regression function, so we write feature call year experience. So we need to input variable X year experience presenting feature calls. So this is our X, feature calls, and our target is salary. We need X and Y. So this is instruction from sklearn.linear model import linear regression. So this is how we call the library. We call linear regression function will present inline regression. Line regression.fix meaning is train our data so will presenting and send all the record. This will print the result to x859.5261. This is intercept x731.9410. This is slope. y equal to x731.9410 x plus 2xx59.5261. So this is what we get from the equation.
Hi, Assalamualaikum to Dr. Muhammad Farhan. My name is Nur Shadwani Zahira binti Zafri. My metric number is 277284. Now, I want to continue to present our assignment 2 for data splitting, the model using 3 performance metric, what the best model and what the knowledge that my friend and I have gained from this learning and how it can be applied in real world. In this assignment 2, the type of learning for our data is supervised learning because we want to get the target. Now we do the data splitting into train and test. In our presentation, we split into 5 sets. First, I will explain about set 1, 40% train and 60% test. First, we import to library, train and test. Split the data into X train, X test, Y train, Y test, and then we put the size 60%, the balance 40% for train. So we call regression algorithm. After we call regression algorithm, we print the intercept and slope. Intercept is 28502.85 and the slope 9107.63. In this slide, we write the Y prediction. The result is for salary and then at test.count is we want to check the number of tests. The result is 21 for years experience and at train.count for the number of the train. The result is 14 for years experience. But this is not clear when we want to predict. So in this slide, it shows more detail to predict because when we run it, will show the compare between actual and predicted. It's more clearer than before. The value that we produce is the result y equal to mx plus c in the linear regression line. This is bar chart that we compare between actual and predicted. This shows just 10 because we write the f dot head 10. Okay, this is for the data splitting into train and test about set number 2. And set number 2 is 50% train and 50% test. In the set number 2, 3, 4, and 5, we will show to you about more clearer to predict. First, we split the data into X train, X test, Y train, Y test, and test size is 50%. And then we print the intercept and slope. The intercept is 2x937.91 and the slope is 8931.67. In this slide, it will show more detail to predict. When we run it, it will show the compare between actual and predicted. This is a bar chart that we compare between actual and predicted. Third, I will explain about set 3, 17% train and 30% test. First, we import to library and then split the data into X train, X test, Y train, Y test. Then we put the size 30%. After we split the data, we print the intercept and print the slope. The intercept is 30653.80 and the slope is 8528.00. So in this slide, same with set 1 and set 2, result will show the compare between actual and predicted. This is bar chart that we compare between actual and predicted after we do the data splitting into 70% train and 30% test. This is data splitting about set 4, which is 80% train and 20% test. The intercept is 29445.05 and the slope is 8629.79. This is how to predict. When we run it, it will show the compare between actual and predicted. And then the value that produced is the result y equal to mx plus c. This is bar chart after we do the data splitting into 80% and 20%. Lastly, about data splitting, train and test, this is set by uh, 90% train and 10% test. First, we import to library, train and test, and then we split the data into X train, X test, Y train, and Y test. Then we put the size into 10%. Then we call the regression algorithm. After we call regression algorithm, we print the intercept and slope. The intercept is 29282.88 and the slope is 8656.54. This is show the compare between actual and predicted. This is bar chart that we compare between actual and predicted after we do data splitting. This is the scatter plot. The point is far away with line. This show high arrow. This line regression get after run regression dot fit. This is a error rate value. First we call the library from scalene import metric, and then we print mean absolute error, print mean squared error, and print root mean squared error. Uh, all three model is a high error rate because uh, I see the value is far away from zero. The best model using three performance metric is mean absolute error because the error rate less than 2 model which is mean squared error and root mean squared error. What is knowledge that I have gained from this learning? The knowledge that I have gained from this learning is that we are able to handle data, access data efficiently, and use it for self-learning. Uh, how can it be applied in the real world? Uh, from this learning, we can make an assessment of a learning in the real world. When we make an assessment, we can know which one are better used and which one are not well used. That's all from our group presentation. Thank you.